I'm going to talk to you about surviving microservices, or trying to. I have a pretty large team. We've been working together for about 3-4 years on various sizes and shapes. And that's kind of the source of a lot of the things I'm going to talk about. So, without further ado, the triple constraint theory tells us we get to choose 2 out of this list, right? Cheap, fast, or good. We know we can do bad things, you know, fast and cheaply, right? We know that we can take longer to make it better and keep it sort of cheap. And we know that we can sometimes add resources and money and experts and do something faster and better. But with microservices solutions, it's a little bit different. We don't really get the luxury of 2. Because you're going to be learning a lot of new platforms and tools and processes. You're going to be needing to kind of change the way you approach development as a whole. You're going to need to, I don't know, automate everything, literally, the world. You're going to need instrumentation, visibility into logs, and so on. So a lot of this just takes time, right? So no matter how you slice it, if you don't do it well, you're going to probably have trouble in production, right? Without the instrumentation and the automation. Too many moving parts, right? And we know that it's not going to be fast because there's a lot to learn and time to get all this sorted out correctly. And so therefore, I can assure you it's not going to be cheap either, right? So your first foray into this is probably going to be an interesting one. And with all that good news, let me say it's still worth it on the other side if you're doing it for the right reasons and if it benefits the business, right? So when you play this game of microservices, you have to play to win. And if you play to win, then you have a chance of doing so. Otherwise, you have a pretty good chance of failure. So that's why I like to play it. And the way we do that is we try not to make impulsive and poor decisions. We hope, right, that we're going to, you know, not just throw a bunch of containers in the cloud and call that a microservices solution. It doesn't work that way. And frankly, when you rush into things, that just doesn't really go well for you, typically. So maybe not even past the first season. But if you take the time to strategize and plan and make an effort to, you know, collect your thoughts and your designs and your team and your expertise and are a little bit more methodical about it, then you do have a chance of succeeding. So you have to at least do that. And plus, maybe, if you're lucky, you have dragons. And if I'm going to production with a large microservices solution with thousands of running containers and clusters in the hundreds or thousands, then I'm going to be the one with the dragons, if I can. So with that, what do we want to survive? How do we do this? And the way that I usually approach it is we have to start with something that gets live. You have to go to production with something. Something small, something manageable, some sort of MVP. And that MVP, that minimum viable product, has to have some business value. And that MVP has a catch to it. It can't just be a simple thing you throw in the cloud and say, look, Ma, I do containers now. But you actually take the trouble to go through the reasoning, the design, the development practices, the automation, the telemetry, and some of the new patterns and practices that you need to follow as a person doing microservices now, right? And get that live. So let's talk about how we survive why. This is possibly the most important question that you will answer, believe it or not. And I know you're all technical people going, yeah, whatever. I don't care why. I just want to do containers. It's cool. And you know, sometimes people do that. You had me at Docker, right? Cool, let's do it. It makes sense. Everybody else is doing it. And if you think that's not enough of a reason, there's all kinds of ways to go on the internet and find reasons to do Docker, right? So, you know, lots of trends and analysis on how many larger companies are doing it and how many people are adopting container platforms. And oh, look, after I use Docker, look how much more later we use Docker. So yeah, it's a good thing. And yeah, a lot of people are doing it, but that doesn't mean it's going to make you successful as a business. So with that, all of these statistics we can gather and find, you know, we get this thing called microservices envy, and then we decide we have to do it too, and then we realize, oh wait, maybe I could have just put that in an app service, and I would have actually shipped a product this year. So you have to ask yourself the question, do I really need it, right? So let's just say we get past that point and we think we're on the road to, I need a microservices solution. You know, we still just don't say, hey, let's throw containers in the cloud any more than we just, grab a couple of dragon eggs, throw it on the fire, and hope that they'll grow big and follow me and do whatever I say. We do need some reasons. We need some foundational reasons why this is a good thing. And there's a couple of really good, well-known reasons why microservice solutions have benefits, right? Things like the fact that we're thinking differently about domains and we're aligning our capabilities of the business to the actual delivery of software. We're talking about frequent releases, right? And making those releases more reliable, resilient. We're talking about, being able to use whatever the right language or tool for the job, being able to normalize our DevOps around one set of technologies, even if you use different technologies underneath. All these things, bring efficiencies. These are good things. And they're made possible because we have containers, because we have Docker, because we have platforms that support the deployment of containers and manage their life cycle and their health, and because we have new operational practices that come around with that and the tools and new design practices, right, that we've kind of been learning over these years. And still, even with that, that doesn't mean that these are reason enough for the business. These are tactical. So while these are all benefits, they don't tell my business, my CEO, my board of directors how this helps them. And if you don't get that far, depending on the size of your business, right? Mileage may vary how far up you have to go. You still have to prove that this is going to have some benefit on the other side. So what we have to do is reach a wider audience, right? We have to have a message that resonates to more. Like, okay, fine. I do want to align my business capabilities with features because we're not meeting customer needs. And where specifically? Where's the money? Where's the cost savings? Where's the benefit? Is it because, we've had some folks where literally they just need to take out one functionality like that's causing a lot of support calls, reset password. I've literally had people just need that to pull out of the monolith because it's costing them so much money in support calls. And just by moving that one thing out into a microservice or nanoservice, they're able to save costs, right? Could be that small. But you have to tie it to the business. Frequent releases with confidence, right? We have risk in our releases, but let's point out where and why and how this is going to fix it. When we have trouble with troubleshooting, it's not enough to say, we know that tracing will help us in production, but how about there's all kinds of wrong when we have to go to a developer to do forensic studies in production data that they shouldn't even have access to, in order to figure out why the data over here is incorrect and over here it's something else and it's causing a problem with one of our largest companies or customers. So why is that? Because we don't have telemetry, we don't have information into what's going on under the hood, we don't have alerts, and so maybe that one piece that is problematic, we're going to fix that. And now there's something the company can tie to either revenue cost savings or customer retention. And then, of course, DevOps tools, yeah, if we can normalize that into one set, then obviously we don't have to learn 10 different ways to deploy. The fragility of, things that run in a legacy app, containerize that stuff so that we don't have to rebuild machines a certain way with scripts. The script is the Docker file, and then we get some benefits. So tie these things to revenue, to cost savings, to problems the company can solve, and now you might have the company behind you. And the reason you need that, and why I emphasize it so much, is because you're going to spend a lot of money and time to do like 10 services, maybe, to production. And they're going to say, what did I get? And if they don't see the value on the other side of that, guess who pulls the plug on your fun Kubernetes, project, right? Let's go back to the old way. This isn't worth it. So I've seen that happen. So that's still not enough. You don't have your dragon yet because you still may need to prove some more. If you're a large company, we have a whole nother set of problems. Like we need to take the monolith and do code analysis and level of effort by domain and how many lines of code are we transforming and estimate the effort to move those to microservices ahead of the 4-year plan. Get a whole resource plan together. How many team members do we need? How many are consultants? How many are not? We got to get a strategy and a roadmap together. We got to do cost projections for 4 years. We got to take that to the board of directors. We got to actually tell them when the ROI comes back. So we've had to do this, but for large companies. So you can see that the gamut varies, but the message is the same. The business has to support what we're doing. or after we spend all the money in the first 9 months just to get an MVP live, they're going to say, what did I get? Or why are we doing it? All right, moving on. We know why we're doing it now. And so we need to survive the design phase. And design could be, you know, starting out as easy, right? We need to identify our business domains. And if we're in, say, some sort of online marketing or sales, you know, we're going to have domains around product catalogs and recommendations and shopping carts and payments and orders and, you know, supply chain to fulfill and ship things, and then customers, and then everybody's got identity, right? So everybody probably has an identity domain or something like that. So we all have users that have to log in and manage permissions and so on, right? So when we think about getting the high-level domains, you're thinking about business capabilities in your org. It doesn't look like this, it looks like yours. But then we still have to go down to what's my subdomains, right? So identity, as an example, we all understand identity, so let's think about that. What are the subdomains? Wait a minute, nobody told me there were subdomains when I read all those books on microservices. Well, because it's nuanced, right? But think about it, a domain team should be what? A UX developer, 2 back-end devs, a DevOps person, a test person, an architect, and a PO, right? Product owner. That team, what can they ship? Can they ship all of this? I need single sign-on, I need user management, I need user self-service, and then I need permissions, and then I need profile. The answer is yes, if it's small enough. But what if, you know, permissions is for 200 different applications with many variations of permissions and hierarchy and multi-tenancy and external administration of that with your customers? Now it's a bigger thing. We need a whole team for that. What if we have profile means more than that? It's CRM integration and accounts and stuff. So we start thinking, well, I have an identity domain, but I have, you know, these things around protocol and users, and then I have these permission things, and I have these, you know, user profile things, and, you know, maybe I have 3 teams in that domain. It's kind of similar stuff, but we're going to break it up. It's nuanced. And once we do that, then we need to get into what are the resources behind that. I have users and configuration. So my identity domain has a lot about users, right? I've got user permissions, and I've got accounts. So now I've identified maybe the data models. These are the steps we usually go through from the architect side after taking use cases from the product owner. And when we build that, the end result is I've isolated what my entities might look like, what my API contracts might look like for resource management, and now I'm ready to think about the details where it starts to get interesting, right? So I'm going to need to relate one domain to another. I own my data, you own your data. My user ID record has to somehow relate to yours. So we have to deal with those types of things, maybe eventual consistency. We got aggregates, whereby those will be related by ID. That's okay. We're following DDD practices. And every API endpoint can only edit, you know, one aggregate at a time, right? It's a full single transaction. So if I need to go to permissions and, you know, users, I'm going to need to figure out an eventual consistency or some other mechanism, which is where we'll talk about messaging. So there's a lot to do here, and it can be, it sounds like it should be easy, right? Here's my domains, here's my subdomains, here's some data models. But you'll get into arguments about, you know, how things should work. And inevitably, somebody in the room is going to sort of feel like they know everything. And then maybe there's a few that know nothing. You want to be somewhere in the middle, right? And what I've seen is an architect who was part of the original system literally tell me when we go to the whiteboard, okay, I have a suggestion. Why don't we tease this out over here? That will be more efficient. No, 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 we can't do that. I wrote the original system. It has to work exactly this way because that's how the users operate. There's no other way. And then literally 3 hours later in the same room, when all the stakeholders were present and the same subject came up, they said, oh, I don't even use that feature because it doesn't work how I want. And so we instead have this spreadsheet that we manage and we write to and we export and we print and we import over here because the code doesn't do what we want. So they didn't even know, right? So if you bring everybody together, the product owners, the architects, the developers, the test, interesting things will happen, and you might even be able to take a step back and get unstuck from how your system works today if you're migrating into how it should work, and start teasing those things out into their own microservices. So Now, let's talk about the actual architecture of the services. So it starts to get maybe interesting when you have discussions about how many microservices do we have in this domain and what should they do? The easiest way to start is with your resource services, right? Let's take identity as an example. So I'm just using that since it's well known. We need a config for all the apps that are allowed to talk to it, and we need users. So those are 2 microservices, right? 2 resource services. And I can add new UIs to talk to those services, and that will give me an opportunity to build new UI front ends to the microservice backend. Then we get into maybe the discussion of, well, the shape of those UI, those APIs shouldn't be the same. One is a read path optimized for read, right? 20 million users logging in, getting config and, validated that the application can make that call. And then, the actual management of those apps, which might be hundreds of users. So we might shape the API, CRUD over here, read over here. And that'll work. So now it's one microservice with 2 API controllers, maybe the same host, maybe not. These are questions. Decisions have to be made. And then on the other side, we might do the same with users, right? Those are different shaped API. One is for user self-service, my profile management. The other is somebody managing my user account and disabling me. The other one is a login with protocol stuff. So they're very different, but I can shape them in controllers, host them together, and later position myself for breaking them out. And then the question becomes, when do I need to break them out? What if I need to optimize the read path for login? So what I want to do is maybe use a CQRS pattern where I have a write store and I have my configuration app writing with messages that won't get in the way of the read path. And then that will eventually update the write store with the new applications that are allowed to call login, and on the query side, we can optimize. So that would be a simple example of a CQRS pattern that maybe benefits me in my config example here, right? So now I have a microservice with 2 API hosts, a shared backend, but decoupling with messages. The other pattern that we see a lot, though, is that when we look on the user side of that, it's a little bit different. I was going to say before that you could further optimize this by using write and read stores, right? So you could instead have the write side write to a write store, and then have the same message eventually project either from outside of the store, like outside of the database as a trigger, or the other side, just the message is being processed and producing the read store. So in either way, this would just be, the reason I would go down this path would be because I'm maybe struggling with optimizing the read side cost-wise, right? I don't want to use the same database. Cosmos is great for writing and flexibility with the store structure, but then maybe my read side, I need it to be optimized, and a SQL database backend is going to give me a better overall cost structure. So I need to, maybe separate those. So I'm going to take the write store system of record differently from the read store. Could also just be for scale, right? So these are just reasons that you might take it another level. The rule of thumb I usually use is don't take it further than you have to, so that you can evolve into the complexity instead of starting with it. So another side of this is, what do I do with users? What's the system of record, right? So on the config side, config is obviously the write store, it's a system of record. On the user side, now I might have 3 different stores, one for my profile management, another for user management, another for just login stuff. So if I do that, then I need to do something for eventual consistency between these two. I have to synchronize them somehow. And this pattern works. Why would I do it? I would do it because I want to start with the read store for just users and logins, and eventually I need to build these other systems like self-service and so on. And as I add those things, I'm not coupled to the one data store that's used for login, and I can let that be highly optimized for 20 million users, 2,500 requests per second type, experiences. And then I can have a separate parallel thread where I optimize my user management, separate feature development, separate lifecycle, separate database, and we just know that certain changes to that have to filter over to the login side, like if I reset my password or something like that. So the point is, I would love if every microservice could just own its own data, but the only way I can get my head around that is if each of those microservices if I know I can make them eventually consistent with the other data stores. So I have to go down that path in order to be okay with this. And then I can free my mind to say each of these microservices have their own document database shape. And I'm okay with that. I'll figure out the eventually consistent part later when we finish figuring out what's our model that we need. So you remove the complexity of the thinking around design. When we get to, sort of really evaluating this, the other thing we're going to come into is, I might have the optimized read side, but then I'm going to have, the system of record being the user. So in this case, I now have only one synchronization to do and a shared backend. So you can see that there's different choices here, right? In this particular path, the system of record is users, and the user runtime is acting sort of like a non-authoritative cache, which is another pattern. So anytime you build a read store or a projection of some set of messages or other activity in the system, you're potentially saying, look, I have this one system of record, and that's the law around this domain model or data model, but I'm able to, at any time, spin up new experiences alongside for other purposes. We call that a fit-for-purpose backend or data model. So I might have a resources API, I might have an experience API, and the resource API for users would just project over to the read store fit for purpose for login performance. And this would then be, two types of services. The other thing you can do is, instead of eventual consistency, you can make it so that the experience API calls direct to the resource API, and then you don't have to deal with the messaging side. That's more real time. So why do I bring this up now? I bring it up because experience services and resource services, this is one way you can look at your microservices topology, but you need to understand those patterns in order to think about how can I solve this problem. So this would be the example where users has a resource service and there's no eventual consistency needed. You have the one system of record and a microservice in front. And then the other pattern would be, I need eventual consistency. Each of my microservices own their own data. Let's not worry about the rest until we need to, integrate. And we'll talk about how we do the eventual consistency side. So with all of that, the detail behind it is actually less important than the fact that now we get to, how am I going to do this myself? So there's a lot of nuances. That was just identity, something simple to show that there's all these little things to think about. And you're going to have hundreds more of those conversations in a real system with lots and lots of actual domains and things to do. And you're going to argue about it, and you're not going to be sure. And you're going to think about the microservices law, which is, every microservice should have one job. Well, what does that mean? One endpoint? Could be. Could it be just it's a resource service or it's not? Could be. Could it mean I have several services like CQRS, a read and a write side, clumped together, and that's still considered logically one microservice and it's always deploying together? Could be. You're not going to know. And you need to be okay with that. Because anything you don't like, you can fix later. All the theories that we read are good, but when you get down to it, you have to make an actual decision about something you're not sure about. So the more important thing to get comfortable with is being wrong and refactoring and thinking and taking a step back, because the whole point of automating all this stuff and making it smooth and making it easy to make change, easy doesn't happen till after your 9 months or so, by the way. It's going to take you 9 months just to get comfortable automating and configuring and monitoring and looking at logs and understanding how to find stuff that's going on. If you can't make it through the 9 months, then, don't bother. You make it through that, all the change stuff doesn't matter after, because you're going to know how to do it and do it without breaking the system. So, it wasn't really a design session, just one to put you through a slight bit of pain before we, talk about why it's okay to have pain. So I guess the bottom line is there's a lot of principles and practices. I've seen people sit in a room and take months to make one decision. I'm not kidding, months about one workflow, not like 8 hours a day, but you know what I mean, time span. Because they just are afraid to make a decision. And if you stand on the principles too far, like, oh, but that's not what they say you're supposed to do, then you're never going to make a decision. And if you have no principles, that's not good either. So how about we say neither of those things are good, and let's try to be somewhere in the middle and get stuff done. Okay. So given that it's probably inevitable some piece of your system is going to need to have eventual consistency, you're going to need to ship microservices that have their own data they care about. You want that freedom. Therefore, you have to embrace that in some way we will need to embrace eventual consistency, whereby I change something here and somebody over there needs to know about that and update their microservice backend. Or I might be integrating on-prem and cloud systems and need a synchronization that's ongoing until we throw away the old system. That could take 4 years, 5 years, in some cases, if it's big enough. So, how do we survive this, right? Data parity is your goal. And there's a couple of patterns you could be aware of, right? You can be aware of the experience API. It's just a fancy way of saying it's not my system of record, but it's an API that fit for purpose knows what data I need just for this use case, this mobile device, this particular UI, this dashboard. And I'm going to get that data from wherever I need it. I'll figure out how, but don't be afraid to create these. These are good. The other thing is, maybe I'm just doing data sync. Like I said, on-prem system cloud, right? That's another thing. Another is I just use messaging as a way to do all the writes for the critical areas that might need to be projected in 5 million different ways, or that's an exaggeration, 20 different ways. And when that happens, you know, we use messaging. So we have, in some form, messages that are the rights of all the user changes. Change my password, you know, change my profile, change my email. And we're going to project those to the write stores or the read stores so that we have access to them in more than one front-end service. Or you can use something like Event Store where, and we've done this for other customers, where we have the actual system of record is the messages. And the messages are, when aggregated, the source of truth, like what's the user's latest email or password or whatnot. And in that case, everything on the other side is a read store because you're projecting that from the messages, but the actual source of truth is you go directly against the messages themselves. So platforms tailored for that are also really helpful in this problem space. And then you have new APIs that come up against the system of record to see the latest and greatest, no cache. Now, with all that being said, the theories of eventual consistency that help us build services that can own their own data so that I can sort of be fit for purpose and make sure we get updates to the right place gives us another benefit too. If we start writing with messages on the CQRS pattern and save those messages so we can project new data, then I will never have to write code to update a history table again in line with my other logic, right? Just save the messages. The messages become your, you know, history table. I write messages whenever I update a user record in this view, and I take those messages and I project them out to the read stores, and then I'm able to take every action that happened, turn it into an audit, turn it into a history table, boom. So there's a lot of value in, you know, data that you would normally audit or need history of every change using messaging around that. Plus you get the eventual consistency projections. Okay. So design is hard. There's a lot of things to think about. You want to consider eventual consistency. You want to consider just the fact that decisions are hard. And you don't have to, if you decide to use messaging, put it everywhere just because you have it. Okay? Some places might be good for a service bus. Other places might be better for an event stream. It might depend. And that's okay too. So let's talk about development. We need to agree pretty early on any of the patterns that we're going to follow, because if we don't, you're going to have chaos. If you have a company that maybe has 10, 12 domain teams, you know, some 70 developers or something like that, then, you know, up front and early, you got to decide, how are we going to govern this? How am I going to manage all the hundreds of API contracts? Are we going to use API contract first? Are we going to define the open API contracts, manage them at the architect level, use code gen to produce the frame so that we always know what the source of truth is across the org and we can publish available APIs? That's very formal, right? That's a lot of work. Don't have to do that, but large companies benefit hugely from that because they need the visibility and they need the governance, and that's the only way to get those practices in place. How are we going to, which development tools are we using, right? Are we going to use Docker locally? Are we going to use Kubernetes locally when we're testing, right? Are we going, what's our process for development? Are we going to debug with our logs? Can we agree to that, for goodness sake, right? Are we going to use messaging or not? How are we going to secure our APIs? Are we using token-based, security and middleware, or are we going to use an API gateway? What's the patterns that we want to embrace? Guess when you come up with those patterns? The first 9 months, the MVP, that's what you're building. You're not just putting something live that has a couple services that does some stuff so that business can say, hey, I see we have a container cluster and some stuff out there. That's awesome. What they want is, I automated that thing, I deployed it, I have instrumentation visibility, we have good development practices in place with this first team, and now we're able to scale that across everybody else because we've learned. And we figured out what we like and we figured out what we don't like over 9 months. Not kidding, right? Get that done, put it in place, and then, we can agree. I've seen people where we've taken time just to decide repository names. I'm almost, aghast about that, but it does happen. How should we break up all the domains? We have 10 teams. Should we have a project in DevOps per team? Or should we just have one DevOps project and many repositories? I don't know what to do. Wait. Weeks pass. Can we just do something? So then you do something, and you know what? After all the thinking and doing, guess what happened? Refactor it anyways. Doesn't matter. Make a decision. Get it out there. You're going to make a change. It's okay. The first 9 months especially, right? Just do stuff. And then try to keep track of tech debt. So, every microservice in the hundreds, you got to figure out how you're going to manage that. A repo per microservice? Probably, so you can have your repo, Docker file, etc. Group them together under a domain, get your common stuff into a central area, and then every service repository with the Docker file becomes an image repository and has a pipeline for deployment according to what the grouping is. So that's the idea, right? Make a decision. The other thing that will pop up is, how are we going to develop locally? If I have a whole lot of local, let's say my system, my solution has some 10, 20 services to run, and I need to get tokens to call APIs, so I need to locally run identity server, get the tokens, make the calls to the APIs. It's complicated, right? But it doesn't have to be. If somebody puts the time into taking that source, getting a local experience where we can compose up or cube deploy on our machine, then I can go to any of you, say, go to the repo, git pull compose up, git put cube deploy, and you've got the whole thing running with seed data. And then that means we're onboarding quickly, we're able to run end-to-end more quickly, but you're only going to get there if you commit to doing it as a team. It doesn't work if you sort of decide to do it and then nobody's paying attention, and then the next time somebody tries to get something done, it's not working with Compose Up, so then they just debug in Visual Studio because it was easier. Or I couldn't debug with the logs, I'm not used to that. We don't take the time to stop, show everybody how to do that, and so then they don't do it, and then nobody's doing it, and then nobody's taking care of the containers in the local story, and then next thing you know, we have bad logs in prod because nobody cared. So you have to make an effort and take the pain early, right? The point is, you can get the works on my machine experience with all these things you need, right? My APIs, my UIs, against my backends, whether it's SQL or logging with Elk or whatever. And then, have a better success story in production ultimately because you've taken the time. What it looks like is this, right? I deploy all these containers, I deploy a Postgres locally, I ship out, some seed data when we run, and a single command gets all this up and running. Takes a bit of time, first time, but once you get that pattern in place, it's good for you. So I would say that's a high recommendation, but you got to take the time. Image registries, that's easy, right? Locally, I'm going to have access to the dev registry. I'm going to build images, test my stuff, my API, my backend, and I'm going to push it to a registry and deploy to dev. When I deploy to dev, it's probably going to get automated, so I'm going to get CI/CD pipelines in place early against the dev registry, and that's going to push to, you know, latest in dev. So dev would always have latest. Every time I check in, it goes to dev. Every time you check in, it goes to dev. If our services call each other, we hope it works. And then we find out early when we break each other, and then we put gates in place to prevent that, right? That should be part of the unit tests or the end-to-end unit tests or release pipeline tests. So these are all things you do. At the end of it, my prod registry is the one we care about the most, because my prod registry is going to be the one where, you know, latest goes to dev from the dev registry, and prod registry goes to test and stage and whatever gates you have along the way, and then finally to prod. But what we never do is we never put latest in prod, because the latest tag is special, right? It's automatically applied typically, unless you change how your CI/CD works by default. And then I've had people call and say, oh, I've got a problem with our, I don't know, identity server solution. Do you think you can help us troubleshoot? I wasn't responsible for the CI/CD portion of this particular customer, so we were just saying, okay, maybe there's a bug in the code, let's go take a look. And next thing you know, somebody in a different branch committed something to the registry. They didn't isolate their dev and prod registries, oops, and it tagged latest, oops number 2, and oops number 3, prod was pulling latest, so it got half-baked code accidentally. So if you just never use latest, you can avoid that problem. So I'll just make that statement again. Don't use latest in prod. Everybody wins. Good. And that will be something that might have saved you a week someday in your future. Just, you're welcome. So the other thing that people get upset about is we're not supposed to share code in, you know, microservices, right? But what does that mean, really? It means, you know, we need a process for package management sharing, right? Not everything can be a sidecar, right? So we need possibly the ability to do token authorization the same way across every API. I'm going to have NuGet packages. I'm going to have a NuGet release or NPM release for shared stuff, and that will solve that problem. So just don't get hung up on no code sharing, and just, you know, understand that if you start out with the code in a shared library, you can eventually move that out to NuGet and make it shared across everybody. And prepare to refactor. So this is the other thing that in development we have to learn, and that is you will refactor again and again and again and again and again. And it's okay. Track your tech debt. Try to avoid too much of it, right? Make decisions, because they help you go live. Going live is more important than not going live, so therefore. And another thing that helps us with the refactoring thing is API contract code gen. So I'm really a big fan of this. Define your resource contracts early, right? What's a user? What are all these resources in our system? What's the CRUD access pattern? What are the routes we want to use? And then get that all code genned with some open API tool, Swagger or Open API. And what we do usually is we'll produce the client libraries for JavaScript, the security required for sending tokens, the server-side host so that it has good practices for bootstrapping, whether it be Java, Dropwizard, .NET, the, you know, actual messaging contracts, or even your data model contracts, right? So the payloads that go into the API, obviously. And we get all of that into CodeGen. And then we put the security around it too, and the telemetry as well. So that way, an architect can go across all the APIs and see the patterns of the routes, and see where we're dumping telemetry and what kinds of, you know, security we have across these. The things that you can do in a contract, do in a contract, and then emit it as code. And then refactoring is less painful, because if you make such a change, it can be a contract commit, CodeGen output out, and then now you go to a new branch, pull that and go. So there's some interesting patterns you can do to get over the refactor as a problem. Now, ultimately, all of the design and development and the pain that goes into this, all this first 9 months is worth it, because then on the other side of it, you've got patterns, practices, and everybody can get lift off quickly. This is what we want. But none of it's going to be okay unless we can troubleshoot in production. You might agree. So if there's one thing we know about logs, you have to write them or you don't have them. So the first thing to do is make sure that your actual APIs and applications have the right logging in place, whatever you're using, Serilog or otherwise, and that you can write it out to something locally to practice with, like Elk, and that you can obviously go to Azure or Amazon and push it out to the target that you're planning to use, whether it be Splunk, whether it be App Insights, whether it be Elastic. So have your logs, good. We need end-to-end tracing. Be very mindful of this. You get it for free with some tools, and OpenTrace is also helping with that story, but it's not totally free. You have to put a little effort. And what we're looking for is things like this. A first login to identity server will make a call, go load the config until it's cached, and then it will, go call the user API. Is the password matching? Are you active, and what's your profile? But what I want to know is if I fail at a certain spot, I want to know how I got there. So I want to know, how did I get to that one piece of failure? And the way to do that is with, a single identifier for the activity, if necessary, all the way through to messaging. And then that way I can trace back. And if I can get that in production, developers aren't going to get calls, why is this failing? And ops people are going to be able to see what's going on. And you're going to be able to, solve problems more quickly. So look for that end-to-end trace story all the way for a single activity, troubleshoot with your logs, and you will make the logs better. And the other thing is, logs should be meaningful, right? That's a meaningful log. Why did that password's, creation fail? That's not so meaningful. Maybe I should fix that. That's not so meaningful. So, this is the poor man's log. If my logs are actually good, I don't have to put crap logs, like I got here, and I got here, and I got here, and oh, I got here too. Because then I have to go look at the code to figure out where did I get, and how did I go, and what. So you don't need those logs if you debug with your logs and make your logs better. So, you'll find interesting things when you look at your logs. Like, how many of those got here statements do I have that I need to strip out immediately? Why do I have duplicate logs? Let's have a pattern. Which layer should actually write the log message? Why do I have a password in the log? How many people have ever seen that one? Yeah, that happens. I've never done it, but it happens. So, and then once you learn your logs and get familiar with your logs, you're going to build dashboards, but you're not going to know what how many people have had somebody say, I want dashboards, before you even have even looked or explored the actual logs coming out? I mean, the next time I hear, we're going to production, can you prepare all the alerts? Honestly, you don't do that until you know the personality of the system. You have to learn what you're looking for, and then you build dashboards, and then you build queries and repeatable, reusable queries. You have to have a target. How do you get the target before you go live? Okay, I'm going to say it again. You debug with your logs, right? You start learning the things you needed to look for to solve a problem, and you make it better. Okay, so the last thing is we need telemetry. And this is really important for just overall understanding of sometimes things as simple as memory use or endpoints that are having success or fail calls. Those are good audit targets as well. We want to know, the error counts. We want to know even customer or consumer adoption of your APIs. Oh, this API is called more by these customers than those customers. This API is called, more frequently internally. Maybe we don't need to expose it externally anymore. So you're going to learn things about how your microservice holistic solution works if you do that. And so we like logs, we like telemetry, and we want to do well with that. And now we need to go live. But before we go live, we have to make sure everything integrates. I built my services, you built your services, end-to-end has to work, and we have to survive the integration. And one of the biggest things that can go wrong is when we have a API endpoint that I've done my unit testing, right? Like I've got my feature, my functional test, my internal integration test, my unit tests. I've thought of every way that I can use this API possible, which means it's going to work for me all the time. But is it going to work for anybody else that consumes the API? And this is important. In a microservices world, the use cases where your API should be used ought to be provided by the consumer of the API. So the service consumers need to say, I'm going to use this resource API in this way. And if they do that, then you can build tests to satisfy the way people said they want to use it to make sure your tests are complete. Why are we doing that? Because we want to go to production and we want to know that when I have thousands of services running, that I can deploy independently and not care about your service and my service. My service needs to do what I set out to make it do based on what you said what you wanted it to do. Now, is that going to be perfect? I mean, you know, we've got our unit tests, we've got the tests that we add based on, you know, what you said you wanted to do with it. It's going to get close, right? And we're probably going to avoid this, which is, you know, we go live and everything's falling apart. But guess what? You have to be prepared. It's still going to go wrong in prod. So what's the most important thing I need to be able to do? Roll forward quickly, like super fast. Everything's automated, right? Visibility, why is it failing? Quickly, learn early before you go live, debug with your logs, I said it again. And, you know, make sure that you're okay with some chaos in production. That's the thing, right? You're going to do some debugging or, you know, troubleshooting, and it's going to be in production. That's what you need to get good at as a company. Every domain team has a subset of things to care about. That means it's a small, tight, exceptionally well-tuned machine that should be able to solve its problems quickly. I can find that quickly for you. It's a team effort. So once you've got your integration sorted and you've done the best you can to get integration tests the way people are going to use your services, now we're ready to go live, we're going to open the gates, and at the end of it, you know, my solution's going live and here's all my users, and I'm sort of bracing myself, right, for what's going to happen, especially if I already had, you know, a user base. So if I already had 20 million users, then when I go live, unless I do some sort of canary sort of deployment where I can, you know, funnel traffic of a subset of users at first, which is an option as well, then I'm bracing myself to see if this is all going to go together. And luckily, it should only be the MVP part. And I should have my feature flags ready to disable the thing, especially if it's our first go live. And I think you know, if you've done all the things I talked about so far, we feel pretty ready, right? We're going to see, like, I'm not going to have trouble in production because I've done all the things I could possibly do. But something will maybe still go wrong. So how do we prepare for load and success in production? I've got this new infrastructure. I need to practice my drills. I need to make sure I have a DR kind of layout across all the things from data through to, you know, cluster failover in regions, through to what if I have a cluster with thousands of containers and just this one set of domain services for some reason doesn't work on this side? How do I reroute the traffic to the other region? You know, things like that. You're going to make a list, you're going to have the drills ready to go, and you're going to try the most important ones ahead. And then you got to have operating procedures ready for how do I get to logs? How do I get to a node? How do I get into the cluster if I need to see if there's a port taken because, oops, that should never happen, but what if? So do we have access to the things we need? Do the people that need to do it know the logins to do that, right? Are we all set? And if you do all those drills, you know, you're not going to have that experience where you didn't, and, you know, more worries. It's a full-time job before you go live, looking for ways to fail. Somebody should be focused only on everything that could go wrong in the infrastructure, everything that could go wrong in, you know, in the container cluster, because that's a whole thing in itself, right? And where stuff is and logs and so on. So this is a lot of work, but if you do all that, you have a good chance. So to come back to the whole theme of this, right? There's a lot of moving parts. Your MVP is going to take 9 months. It's going to have some subset of services, maybe 10. And it's going to feel like a lot of money and a lot of time to get that done. But that's going to make it good with a small set. And you're going to be automated, and you're going to have telemetry and logging, and you're going to have good development practices, and you're going to get some patterns in place that the whole other set of teams that come on board next can follow. And once that's done, you know, you'll deal with it. But it's not going to be fast because you got to go through the tools and DevOps practices and everything we just talked about. Security hardening is a whole nother one. A lot of work. And then, of course, it won't be cheap because you need probably to bring in help. You got more resources you got to hire. It takes longer to do the first set of things. And those people, when they're on the new microservices project, won't be doing the existing project, so it's going to be a problem. But, you know, at the end of the day, right, you're going to have low defects, you're going to have high throughput, you're going to be faster and more agile deploying new things because you've got all these patterns and practices and automations and pipelines and automated tests in the pipelines and everything with less technical debt than you had before. And, you know, the time that it would take, maybe 1 to 3 quarters for the POC, for the MVP, and then maybe, you know, we're looking at costs that could span, you know, anything from the first, I don't know, first 9 months being just the only thing you care about deploying to it's a 4-year project and it's a monstrous port of a monolith, right? So the cost's going to vary, right? I just threw that up there as ideas. It's going to vary greatly. But that being said, right, I think it's a lot of work to get there, but you can survive if you do all those things. And that's all I got. Thank you.